In a startling announcement that feels ripped from the pages of a science fiction novel, Dr. Elena Mirov, a leading astrophysicist of the European Space Agency, has issued a grave warning about Oumuamua, the mysterious cigar-shaped, interstellar object that soared through our solar system in 2017. Dr. Mirov's research, a collaborative effort that combined data from telescopes around the globe and the latest in computational astrophysics, suggests that AMU is on a potential collision course with Earth, with an estimated impact date in the year 2068. Oumuamua has been an enigma from the start. It's the first known object from another star system to visit ours, and its unusual speed and trajectory have baffled scientists since its discovery. Unlike comets and asteroids that orbit the Sun, Oumuamua's path suggests it originated from outside our solar system and is just passing through. What makes Dr. Mirov's findings particularly shocking is the precision with which she predicts its path, something not typical with such interstellar objects, whose trajectories are notoriously difficult to calculate due to their high velocity and unpredictable behavior, influenced by the gravitational pull of the Sun and planets. Dr. Mirov fused a combination of radar observations and computer simulations to map for Oumuamua's future course. Her findings indicate that not only is Oumuamua hurtling back towards our inner solar system, but it could also come dangerously close to Earth within the next 50 years. The implications of such an event are catastrophic. The collision could release energy equivalent to several thousand nuclear bombs, causing unprecedented devastation. This prediction has sent shockwaves through the scientific community. While many are skeptical, citing the need for further data and confirmation before triggering a global panic, others are taking the warning seriously. Already international groups of astronomers are mobilizing to conduct follow-up observations. Their goal is to refine the calculations of Oumuamua's trajectory and confirm whether Dr. Mirov's chilling prediction might actually come to pass. In the meantime, the broader implications of Dr. Mirov's warning are profound. It underscores the urgent need for advanced monitoring systems to keep a watchful eye on the cosmos, seeking not just to understand the universe's wonders, but also to safeguard our planet from potential interstellar perils. As we continue to explore the vast, uncharted depths of space, Oumuamua reminds us that sometimes the stars gaze back with unpredictable, potentially dire consequences. The prospect of an interstellar object like Oumuamua colliding with Earth is not just the stuff of science fiction, but a scenario that could have tangible and severe consequences for our planet. Though the chances are slim, the impact of such an event could be monumental, echoing the cataclysmic collisions of our planet's geological past. If Oumuamua were on a collision course with Earth, the immediate concern would be the scale of the impact. Unlike most asteroids and comets that belong to our solar system and have predictable paths, Oumuamua's interstellar nature means it travels at a velocity immensely faster than typical near-Earth objects. This increased speed significantly magnifies its potential destructive power. For context, the energy released by a collision would not just be a local or regional issue, but could trigger global consequences. The impact could release energy equivalent to multiple nuclear bombs, leading to devastating tsunamis, earthquakes, and potentially a new volcanic winter. The scientific community has studied similar catastrophic events in Earth's history to understand the potential effects better. The most often cited example is the asteroid impact that led to the extinction of the dinosaurs 66 million years ago. This event triggered nuclear winter effect where debris, dust and ash block sunlight, dramatically altering the climate and leading to massive species extinction. While Oumuamua is smaller than the asteroid, that caused this prehistoric disaster. The velocity at which it travels could compensate for its smaller size, leading to significant atmospheric and environmental changes. Current research and technology are focused on tracking such fast-moving objects more accurately. For instance, advancements in telescope technology, such as those used in the Pan's Observatory that discovered Oumuamua, are crucial. These instruments help scientists detect and monitor objects from distant parts of our galaxy, potentially giving humanity more time to prepare or even avert a catastrophic event. The possibility of an impact also raises concerns about preparedness. As of now, international cooperation in space surveillance is robust, but the technology for deflecting or destroying an incoming interstellar object is still in developmental stages. Theoretically, missions similar to NASA's DART, Double Asteroid Redirection Test, could be designed to alter an object's course. However, the unique challenges posed by Oumuamua, its speed trajectory, and interstellar origin would require unprecedented international scientific collaboration and innovation. While the chances of Oumuamua colliding with Earth remain low, the potential impact could be globally catastrophic, underscoring the importance of continuous monitoring of space and the advancements of technology in asteroid deflection strategies. This scenario serves as a reminder of our vulnerability on a cosmic scale and the critical need for preparedness in the face of unknown interstellar threats. As we contemplate the possible collision course of Oumuamua, the startling reminder of our vulnerability in the vast cosmos comes into sharp focus. Recent discoveries and research, such as the detection of unexpected changes in Oumuamua's trajectory attributed to non-gravitational forces acting on it, underline the complexities of tracking and predicting the paths of interstellar objects. These findings not only broaden our understanding, but also amplify the urgency of developing robust monitoring systems. The discussion surrounding Oumuamua has sparked a global re-evaluation of our preparedness for potential celestial threats. Governments and space agencies worldwide are now prioritizing advancements in space surveillance technologies and exploring collaborative international efforts to enhance Earth's defenses against these unpredictable visitors. This heightened awareness is a testament to the crucial role of ongoing space research and its direct implications for planetary defense. As we navigate the uncertainties of Oumuamua's journey through our solar system, this event serves as a poignant reminder of the importance of vigilance and preparedness in the face of cosmic phenomena. By harnessing the power of global cooperation and cutting-edge technology, we can hope to safeguard our planet from future celestial threats, turning apprehension into action. As we look to the stars, let us move forward with cautious optimism, supported by the relentless pursuit of knowledge and the unyielding spirit of discovery.